Let's talk about some advanced RToken parameters. After having dealt with the revenue distribution in the last video, we're now gonna come across the backing manager and the other parameters sections. These sections are a whole bunch of parameters that you can use to tweak your RToken just right. You'll notice that they have default values. These are the default values that the Reserve core team has thought about. That likely for most RTokens, these default values are right. But again, for your RToken, you might just want to tweak a few of these. Since these parameters are mostly technical in nature, here is Taylor Brent, the lead protocol engineer at Reserve, to walk you through all of them.
Next, I'm talking about how to write collateral plugins. First, before diving into this, I just want to caveat this with writing a collateral plugin is definitely not for a non-technical person to do. You could conceivably succeed in this kind of thing, not being a Solidity developer and basically just being able to read one or two crucial functions off of the underlying DeFi protocol you're trying to build on. But really, it is something that is technical and easy to get wrong in the harder cases, and generally requires someone who is adept at smart contract development. So, without further ado, let's dive in. First, you'll notice I've opened two docs here. Protocol/docs collateral and writing collateral plugins. These are similar to each other. Collateral is epically long, as you can see, and walks through all sorts of cases, does a function by function description and invariant requirements. Whereas writing collateral plugins, this is a bit smaller, still getting this started, but it does have the right questions that you should direct your attention to when writing your collateral plugin. I'm not going to read through this whole document. I'll leave that up to you. I highly recommend, it's basically required reading. Read this accounting units and exchange units. This is, did that link work correctly? Okay, it's supposed to link down here and it's not, but definitely read that section down below. And there we go. Yep, that's good. And then this also is down below. No, this is in Solidity style. Okay, so this is in a new tab. Yeah, and this describes our units. This is also required reading because you need to understand the units that are in the comments. That is basically your guide to staying sane while writing this contract. So first off, if you don't see a Q, then we're talking about whole units, okay? Whole token, whole reference unit, whole target unit, whole basket unit, whole USD in this case. You'll see naming like ref per toc. That's straight up the name of one of the functions here, or target per ref. And these mirror the units that they are. I'll leave this up because the interface is useful. I'm not going to read through everything. I'm just going to give you the rough form of the thing. So the rough form is you have a single mutator function, okay? Single mutator is called refresh. Everything that needs to go do some state update in either this contract or some underlying DeFi protocol has to happen in this function. Every other function, so all of these, and if you're building a collateral, then also these, you'll notice these are all views, okay? And it's expected, actually just straight up at the beginning of any protocol interaction, you're issuing RToken, redeeming RToken, trading, whatever, every single registered asset is refreshed in order to prepare its state for all these functions later on. Okay, exchange rates. So I'm going to assume that you have read about our unit notation at this point, or at least we'll go back to it after if you're confused. There's basically two crucial exchange rates that you'll have to come up with. So I'll do the easier one first. Target per ref. This is usually just going to be a constant. Target per ref is the quantity of whole target units per whole reference units, and this could be documented more clear, in the peg as intended. So this is not like as empirically currently what is the price in the peg, but this is the intended exchange rates. So look, in almost every single case, this is going to be 1. We left it open because, it's conceivable to have a stablecoin that is worth $10. That is a totally coherent idea, and the interface should be able to support it. But you know, you're dealing with a LSD ETH staking derivative, and you think that even that has a 1-to-1 exchange rate between ETH and whatever your reference unit is. I'll dive into Lido in a second, so that'll make more sense. Ref per talk. This is the like up only function on the interface. What ref per talk should do is return the value of some underlying exchange rate in a DeFi protocol that you're building on top of that is itself up only or close to it. I won't explain why the protocol requires this up only assumption, but very shortly, the capital flows do not work out if ref per talk can fall. It introduces an incoherent flow that breaks some of the fundamental assumptions the protocol is making. So ref per talk up only, okay? Collateral statuses. At any given time, a collateral is going to be one of these three states. It's either going to be sound, meaning there's nothing wrong with this collateral, continue using it. Iffy, which is we don't really feel like we need to toss the collateral out just yet, but there's something going on and like maybe the protocol should be a little more careful. And then there's the fully disabled state. Note that it's important that if the collateral is iffy for a sustained period of time, that it eventually becomes disabled. It should not be possible to stay in iffy forever. Basically, the protocol stops actions when something is iffy, and when something is disabled, it allows the protocol to take actions again because it knows what to do. It can just dump that asset and get a new one. Okay, let's close that one. And let's open Lido, I believe. Yeah. So we have written many helpers that, here they are, the top level, okay? These are used by the plugins that are in these folders, okay? So say you're implementing Lido, you might reach into one of these parent classes and inherit from it. In this case, appreciating fiat collateral, because it turns out that wrapped staked ETH for Lido is going to be actually pretty similar to an appreciating fiat collateral. We're just going to have to remove the fiat piece, right? So let's look at appreciating fiat collateral. You'll notice up here at the top, it says can easily be extended by re-implementing, and then has these 4 functions. Should not have to re-implement any other methods. So we're trying to make it easy for people to write new plugins without understanding the entire inheritance hierarchy. Still, I would recommend, if you are looking at a particular class, follow the inheritance hierarchy up until you reach rock bottom or rock top, however you think of it, and figure out what is all the functionality it is inheriting. So in this case, it's actually just telling us, look, these are the only 4 things that you probably need to look at. Try price. This is used by the price function of one of the parent classes in a try catch call in order to see whether we can fetch prices in the current block. If we can't for some reason, or there's an error due to math, or there's an overflow, some price comes back too high, and after multiplying by this, we get a number larger than uint192.max. Then that price function will not revert. It will instead just return 0, fix max. And I should explain that in a second. Here we are. Price, low and high. So you'll notice that we do not use point estimates for prices. Instead, prices are always given in terms of a range. This is usually pretty simple to derive. Generally, you go grab the price in the Chainlink Oracle. It has some deviation associated with it. You subtract that deviation to get the low, you add that deviation to get the high. That is a full price range that the asset could actually have for its price, right? Okay, try price, ref per talk. Maybe you want to override this function, which is, that core up only exchange rates that's going to allow the protocol to identify revenue. And maybe you want to identify target per F. Probably not, though. Like I said, 1-to-1 is basically what everything's going to use. And then claim rewards. If there's some type of reward that can be claimed. Basically, if by holding the collateral token, you earn the right to claim some governance token or reward token, then you're going to have to implement the claim rewards function. Okay, let's look at Lido because it's a simple case. Oh, apparently I can't go back here. Okay, so here's Lido staked ETH collateral. First, I recommend at the very top, using some kind of documentation like this where you explicitly say what the 4 units are equal to. Okay, and as I said before, or maybe didn't, UOA is always USD. These are the 3 units you need to come up with. Read through this doc. Well, these are the questions to ask. Really read through this doc in order to understand deeply what is the TOC and ref and target unit. Like I said, that is explained here under accounting units and exchange rates. I'm not going to read through all this. Just do it yourself. Okay, so first thing you do, you figure out what is my collateral token. Suppose you were following that train of thought for Lido, okay? You might think, okay, great, Lido's got a collateral token, STETH, right? Okay, kind of. STETH is rebasing. One of the constraints of the protocol is it needs to have a token that is non-rebasing. Its balances, it assumes that if it has a balance of a token at time t1, that at time t2 later, if nothing has happened, it still has that balance, right? Rebasing tokens break this invariant. Now, that's okay because it turns out there is a straightforward transformation you can do to go from a rebasing token to an appreciating exchange rate token, something much more similar to like a 4626 vault. And you can go the other way. You can take something that is an appreciating exchange rate and you can turn it into a rebasing token where the exchange rate is always 1-to-1, but the balances are increasing or decreasing over time. So our protocol does not support rebasing tokens. If you have a rebasing token, such as in the case of Aave A tokens from Aave v2, you're going to need to wrap them in order to use that token as collateral. Likewise, for STETH, if you hold in your wallet, will be worth 1.05 STETH. Rather, the balance of STETH in your wallet will be 1.05 at the end of the year. This is a rebasing token and needs to be wrapped to turn into wrapped staked ETH. Now, fortunately, in Lido's case, we don't have to write the wrapper contract ourselves. In the case of Aave v2, we did Compound v3 as well. In Lido, they actually have a canonical or blessed wrapper contract that everyone uses, which is really nice. So it was really natural here to use that as the choice of collateral token. This means, so remember, ref per TOC is the fundamental exchange rate of the protocol that can be used to identify revenue, right? Ref per TOC. How many STETH do we have per wrapped staked ETH? You can see that over time, that is increasing, right? So here we are. This is implementing an internal function because if we read appreciating fiat collateral closely, we'd see that this is the only thing we need to override. But you can see it basically returns STETH per token, which if we grab, we don't actually have the wrapped contract here because we don't need it. We just need the interface. This is the only function we care about. And maybe there's be some conversion into the language that we're used to. So this is going to safe wrap using the fixed library. So protocol contracts libraries fixed.sol. That's our math library. And yeah, this is basically what Lido ended up being, right? It's really simple. So inheritance call for this giant config struct and a revenue hiding amount. I'll talk about revenue hiding to wrap this up. And it turns out that we need one other kind of price, okay, for Lido. This is the price. So you notice this is documented. Good. This is the price between the target and reference unit. Whereas the chainlink feed that is inside this config struct is assumed to be UOA, USD, per reference unit. So, well, what's our reference unit? STETH. So this feed is USD per STETH, whereas this feed, excuse me, is ETH per STETH. Okay? This one is going to be used to check to see whether STETH is defaulting or losing its peg. Basically, what is the exchange rate to ETH, and is it sufficiently deviated for a long enough period of time such that we can use that as evidence that we should dump the token. I keep saying we, but I'm speaking facetiously, or I don't know what the term is there. The protocol should dump the token for something else. And meanwhile, this other price in the Chainlink feed, the USD per STETH, is what's going to be used to provide this low and high price, which looking at our units is USD per TOC. right? So this is, what is the price of this token that's actually being held by the backing manager? Whereas this peg price, this is more like some exchange rates that's then going to go into some logic inside the refresh of a parent class, and it's going to check to see for default. Again, you don't need to worry about that kind of thing, though I do recommend following the inheritance tree all the way. But generally speaking, you should not be surprised if this is all you need to do to implement a collateral plugin. That is not too crazy. Now, I just want to show a harder case. Oh, I was going to talk about revenue hiding. So revenue hiding here, it's a thing in the appreciating fiat collateral class. This is an extension of the fiat collateral class that adds an appreciation element. So the fiat collateral class assumes that the TOC is exactly equal to the ref. In this contract, we're going to say TOC is not equal to ref. And ref per TOC is actually going to return, in this case, exposed reference price, which is going to be a thing that's calculated in the refresh function, but who cares? Basically, this is just some number that's going up over time. Revenue hiding is the idea of having some actual exchange rate that you sort of hide in the background, and you expose a discounted value. What that allows you to do is if there's a decrease in the actual exchange rate, as long as it's less than the amount of revenue you're hiding, then you don't need to disable the collateral. And that's important because something the protocol requires is if ref per TOC falls, the collateral must be marked as disabled. Now, I'm aware I skipped a bunch of these invariants before diving into this. You can read all of that from this document. Please just read this document from top to bottom. It will be very useful, and it will describe all sorts of things like this. Okay. Yes, we're going to talk about what a harder case looks like. So a harder case, compound v3. So compound v3, basic model. There's on the supply side, there's just ETH. And on the borrower side, there's a whole bunch of tokens. So there's some sort of yield-bearing form. I said just ETH. Ooh, just USDC. There's also an ETH instance of Compound v3. So that's not too wrong, but I meant to talk about USDC here. That's called a comet, that USDC, yield-bearing USDC. But it's yield-bearing through rebasing, okay? So if you hold one C USDC v3 at the beginning of the year, maybe you have 1.03 or something by the end of the year, right? This is not going to work for the protocol, so we have to wrap it. Here, by the way, is a great wrapper contract to start with. If you do decide that you need a wrapper contract, start with this Open Zeppelin approved one and extend it from there, okay? So in Compound v3's case, we did need a wrapper. I'm going to open the collateral contract and the wrapper. So you can see the wrapper extends wrapped ERC20, and yet it is still pretty long, okay? And this actually has to do with rewards and calculating exactly how you're going to hand out rewards to who and so on. It honestly gets quite complicated. Hopefully you won't have that kind of case. If you have rewards in a wrapper token, then you have one of the harder cases that can possibly exist. And again, at a high level, what this is doing is transforming a rebasing token into a 4626 like, I'm saying like because it's really only like in the fact that there's an appreciating exchange rate, into an exchange rate token, okay? So here's what the collateral contract ends up being at the end of the day. So you notice it's actually only a bit longer, kind of surprising, not that long. So again, here at the top, write out all the units. The TOC is the wrapped contract. The reference unit is the underlying. This is not correct. This should be CUSDC. Sorry. Okay. Well, anyway, moving on. CUSDC is the reference unit, and the target is USD, and that's because one CUSDC is. I guess it doesn't really matter. Sorry, I shouldn't get hung up on this. It doesn't really matter because USDC and CUSDC are 1-to-1. I guess that's the idea here. Yeah. So since CUSDC, there's an in-between here, right? There's some sort of, and you can have any number of like in-between tokens, right? So you imagine like a ... right? It's like TOC ... ref. It can be any number of wrapping, deposit, whatever steps involved between those. That can all be abstracted away. And the only thing that's shown here is what is the token that's actually held, the ERC20 contract, and then what is that with respect to the reference token, okay? So looking at the actual content here, it ended up being pretty short. I don't think this function is really necessary, so we can skip it. This claim rewards function, right? So on the wrapper, there is a whole bunch of code implemented regarding how to figure out who to give rewards to and how much. Here in the claim rewards function, and this is actually executed via delegate call. This is not super well documented, but you can see here, claim rewards, delegate call. This will always be executed via delegate call from the backing manager. And this is why it's really important for assets to be added by governance and confirmed to not be malicious, because otherwise you can lose everything. So, nope, that's not where we were. So it has a claim rewards function. It's implementing it, assuming that this is executed within the context of the backing manager. And the wrapper contract has been written to claim the tokens and then give them to the backing manager and in the correct amount. This is mentioned in this file, but just say it out loud. A single collateral plugin contract is going to be looked at and used by many different RTokens. Okay, so you cannot privilege a particular RToken or have the collateral contract hold balances itself. Here it's going to override the underlying ref_per_toc function, which if we call back to that appreciating fiat collateral class, is how we're going to pass through the exchange rate prior to revenue hiding. So basically here was the important function to find in Compound v3, right? Or at least in the wrapper contract. This exchange rate function is all that was really needed to get ref_per_toc. And then in refresh, okay, so one, this accrue step is required. It looks like there's actually a mutation you need to do in Compound v3. All this stuff up here is just normal revenue hiding stuff. And here we are, some special default checks. So if the commit reserves is negative, fun, I guess that's what happens when you have an int assigned integer here, is you actually do need to check, see if it's 0, then default immediately, right? Because that is not a valid state. Otherwise, if it's under some sort of thresholds that was set, so these are commit reserves. This is how much USDC is actually residing in the commit for people who came and lent USDC to come back and redeem, right? Redeem their CUSDC v3 for USDC. So you'll notice here this marks it iffy, and that's because this is not a, good enough indication that Compound v3 has broken. But rather, if this is sustained for a period of time, and that's going to be set by one of the variables in the struct, in the constructor, then after you mark iffy for, in this case, like 24 hours, then it will move to the disabled state. And these are what normal dpeg checks look like right here. Notice again, set to iffy, otherwise set to sound. And again, if you looked at the very, very top level, right? So I'm just going to pull up asset for a second. This is the very top level class. All collaterals, I think all, inherit from assets, actually. Let's see, what do we want to look at here? Right, so asset does not have defaulting logic because an asset is not something that can be used to back an RToken, right? But the fiat collateral, and this is the parent class of all the collateral, it's named fiat, but that's just because it starts out sort of with the fiat has the minimal number of assumptions, right? Relative to any of these other tokens. You can see there's some helpers here. Mark status. You should use this, passing in the status to mark it as, and it has its own logic related to updating some internal state and so on to make sure you never do silly things like move it from the disabled state back to sound or iffy. Once disabled, it should remain disabled. That is enforced via this function. You just need to use it via mark status, passing in the status. And you can see here the default values, like I said, 1 for target to ref, 1 for ref_per_toc, since it's non-appreciating, and that's what appreciating fiat collateral comes in and changes, right, and adds the revenue hiding to. And the base refresh function, which is going to be good enough for most cases, but not all. Okay, so I definitely didn't cover everything in this video. There is a lot to figure out while writing a collateral plugin. Please feel free to hop in the Discord. We will answer questions in our technical discussions channel, I believe is the one. And please, before asking questions, read the entirety of this doc and everything linked to within this doc. That will be very, very useful, and you'll come in with the necessary prior knowledge. Okay, thanks.
Once your parameters have been set up correctly, now you can go ahead and deploy the RToken with the Deploy RToken button right here. This is the first transaction that we'll have to sign. Your wallet will ask you to sign this transaction, and it will take a while to confirm the transaction, but once it is, now we can go ahead with deploying governance. Now that the RToken has been deployed, now it's time to deploy the governance contract.